Welcome to a summary of fractions, and what we're looking at today are the different fraction questions that you'll encounter at Foundation GCSE Maths. Okay, let's look at equivalent fractions first. If you look at this diagram here, I have 6 sections shaded out of a total of 10. Now if you look across at this diagram here, it's the same diagram, all I've done is removed this middle line going along. So it's exactly the same. I've just now got, instead of 10, I've got 5 sections with 3 of them shaded. So 6 out of 10 here is the same as 3 out of 5. Now, if you look at this, what I've really done is 10 divided by 2 is 5, 6 divided by 2 is 3. So I've divided the top and the bottom by 2. Or, to get from 3/5 to 6/10, I've timesed 5 by 2 and 3 by 2. Now, with equivalent fractions, as long as you multiply the top and the bottom by the same number, it's exactly the same value of fraction. That is 0.6, that is 0.6. They're both 0.6. I could have multiplied top and bottom here by 10 and written it as 30 over 50. If I do that on a calculator, it still gives me 0.6. Now we're going to use this equivalence to be able to add fractions. You can only add fractions if the bottom number or the denominator is the same. So I've got 3 over 5 plus 1 over 10. Now I know that I could change this 5 to be 10, then they'll both be the same. So if I multiply 5 by 2, I get 10. But I've multiplied the bottom by 2, I must multiply the top by 2 to get 6. So 3 out of 5, same as 6 out of 10, as we're seeing here. So I've now got 6 out of 10 plus 1 out of 10, giving me 7 out of 10. If this was a minus, I'd do exactly the same thing to here, and at the end I would say 6 out of 10 minus 1 out of 10 to give me 5 out of 10. Okay? So whether it's plus or minus, you still do the same method, making sure that the bottom numbers or the denominators are the same. Now, here I've got 5 and 3. I can't just multiply one of them to make it, excuse me, to make it exactly the same as the other. So, what if I multiply 3 by 5 and 5 by 3 to make them both out of 15? Easiest way to think of this is as a cross multiplication method. What I'm doing is I'm multiplying this 5 by 3 to make it out of 15, so I must multiply the top by 3. 3 times 1 is 3. So 1 out of 5 becomes 3 out of 15. Here I multiply the 3 by 5 to get 15, so I must multiply the 2 by 5 to get 10. So 2 out of 3 becomes 10 out of 15. I now have 3 out of 15 plus 10 out of 15, giving me 13 out of 15. Right, here, looking at mixed numbers and improper fractions. An improper fraction is where you have a top number bigger than the bottom. Here I've got 7 over 4, or 7 quarters. A mixed number is where you have whole numbers and fractions. Now 7 over 4, 4 goes into 7 one whole time with 3 remaining. So 7 over 4 is an improper fraction equals 1 whole 1 and 3 quarters as a mixed number. Here I can change back. 2 and 1/6. I want to change that to an improper fraction. Now there are 6 sixths in 1 whole 1, so there are 12 sixths in 2 whole 1s. Plus the 1/6 I've got there gives me 13 sixths. Now there is a trick that I could use. I could say that I multiply the bottom by the whole number and then add the number over the top of the fraction, the numerator. So 6 times 2 is 12, plus 1 is 13. Okay, looking now at multiplying fractions, these are really easy. Excuse me. When you multiply fractions together, all you have to do is just multiply. You don't have to change anything or worry about getting the denominators same or anything. You just multiply. 3 times 1 is 3, 7 times 2 is 14. So that's 3 over 14. If these were mixed numbers, what I have to do is change them to improper fractions before I multiplied. Okay? So as long as you've got either normal fractions or improper fractions, you just multiply. Right, this is a word you may see at foundation, reciprocal. All it means is 1 over. So the reciprocal of 4 is 1 over 4. Reciprocal of 7 would be 1 over 7. Reciprocal of a million, 1 over a million. Be careful when they give you a reciprocal of a fraction or a decimal. Reciprocal of a half is 1 divided by a half, 1 over a half, which is actually 2. So just be careful if they ask you a reciprocal of something that isn't a whole number or an integer. Okay, thank you for listening.